in a very rough sense, a limit is as close as you need to be without actually being there. So a lot of the mathematical principles hold, but you don't have to worry about actually being at the spot. Epsilon delta is usually the formal definition, which we're not going to be studying in this class. Now, limits, you're infinitesimally close to being there, as close as you need to be, but you're not actually there. Whereas function evaluation, you're actually there. Now, as far as notation goes, you would say the limit as x approaches c on f of x is equal to L. So as we approach this x value of c going along our function f, we approach a y value of L. Even though we're not actually getting there, we're approaching close to L. Now f of c, that is when we're actually at x equals c, is equal to m. And so you can see this is called the discontinuity because it's discontinuous. There's a hole there. So let's try to clarify with some examples. We have this function here given in black, and we'll just go through several of these. So the limit as x approaches a of f of x. Well, if you approach from either side, coming from this direction to this direction, either way you get 0. F of a, if you're actually there, you get 0. The limit as x approaches b of f of x, coming from either direction, you're approaching a y value of L. It doesn't matter that there's no point actually there, because you're not actually getting there, but you're approaching a y value of L. Whereas f of b, if you're actually at an x value of b, the y value is m. What this is saying is the limit as x approaches c from the left, from lower numbers. So as you approach c from the left, you're coming this way and you're approaching 0. This is x approaching c from the right, you're coming this way, that's approaching 0. And then the limit just approaching c is, if they're the same from the left and the right, then there you go, it's just 0. Now f of c is also 0. So we'll do a few more. Okay, now we're taking the limit as x approaches 0 from the left. So if you approach 0 from the left, you're coming along here and you're approaching a y value of L. If you take the limit as x approaches 0 from the right, you're coming this direction, you're approaching a y value of m. The actual limit then does not exist. And this is also called the discontinuity, but this is a step discontinuity. It's non-removable because you can't just plug a point in and get these two pieces to match up, whereas this is called a removable discontinuity. This hole is a removable because you can plug it in. F of 0 is actually L, because if you're actually at x value of 0, your y value is L. As x approaches d from either side, it's 0, so the overall limit exists in the 0. As x approaches e from the left, you could put does not exist, but putting positive infinity is a little more descriptive. If you're approaching from the right, you could put does not exist, but negative infinity is a little more descriptive. The overall limit then doesn't exist. You can't put plus or minus infinity, and f of v also does not exist. So we'll look at one more page, some more examples. Okay, for this function, we take a limit as x approaches negative infinity. So if you're going towards negative infinity, then it looks like your y value is approaching 0. If you're approaching a from the left, you're going up to positive infinity, you could say does not exist. If you're approaching a from the right, from above, it's also called, it's positive infinity, so the overall limit to a doesn't exist, or because they're both infinity, you can put infinity. F of a, again, does not exist. Limit as x approaches a of f of x, well, that's the overall limit, so you can, I have that one here, same thing. F of 0 is L, because you're actually there, it's L. The limit as x approaches b from the right, you're coming this way, it's 0. F of b, well, there's no point there. There's no point anywhere when x is b. So that doesn't exist. Limit as x approaches c from the left, or from below, is L. Below means lower numbers. Limit as x approaches c overall, well, it's L from below, it's m from above, from higher numbers, and so the overall limit doesn't exist. F of c, there's no point anywhere, so that does not exist either.